Welcome to Tree Diagram Summary. So here's a little background on tree diagrams. First, conditional probabilities start at their condition. Right? And that means the end. And we'll take a look what that looks like. It makes a lot more sense when we look at a problem. Non-conditional probabilities start at the beginning of the tree. We multiply when moving horizontally across the limb. In other words, if we want to find the probability of this and that, we're going to multiply the probabilities as we move down the limb, move across the limb. If we want to find the probability of this or that, we're going to add the probabilities from the different limbs. Right? So let's take a look at what that looks like with a problem that's in your notes. Jim created the tree diagram after examining years of weather observations in his hometown. The diagram shows the probability of whether a day will begin clear or cloudy, and then the probability of rain on days that begin clear and cloudy. Let's just take a look at this diagram before we solve any problems. So I notice that I have two initial branches to choose from. Right? I either go down the clear branch or the cloudy branch. If I were to add those two values together, the 0.28 plus the 0.72, they add up to 1. That's kind of interesting. So these ones add up to 1. What if I look at the probabilities of any individual branch? So let's say I go down the clear branch, and then it could rain or it could not rain. Right? That's kind of the only two choices, right? Either it's raining or it's not raining. Right? So if I add rain plus not rain on that branch, they add up to 1. How about on the cloudy branch? Does it still work? If I add 0.31 plus 0.69, they add up to 1. So an important thing when we're making a tree diagram is that the sum of the probabilities at any branch and those are the ones that represent our choices. So clear, cloudy, rain, no rain equals 1. Right? So we have our choices are clear or cloudy. Once we choose clear, our choices are rain or no rain. If we choose cloudy, our choices are rain or no rain. Notice that any one of those adds to 1. Any one adds to 1. So I thought that's something important to note. That'll really help us when we're making a tree diagram. All right, so now let's find some probabilities with our tree diagram. And if you're already given a tree diagram, it's really easy to find the probability. So we want to find the probability that a day will start out clear and then will rain. So in other words, we're finding the probability of clear and rain. We know when we see that upside down U, that means intersection, so that is and. So we're going to go down the path that says clear, and we're going to take that probability. And since we want to find the probability of clear and rain, we're going to multiply the two probabilities together. We're going across the branch, we multiply the two probabilities together. Right? And if we multiply those together, we have 0.0112. All right, let's look at the next one. Find the probability that it will not rain on any given day. All right, so I'm going to actually erase this red part here. And I'm going to actually leave the probability. So this probability for clear and rain, that was 0.0112. Let's just leave that over there as well for a moment. And I'm going to erase that branch so that I can write in a different color and I don't have to go over the color that's already there. We want to find the probability that it will not rain on any given day. So we have two paths we could take. The paths containing clear and no rain, and the paths containing cloudy and no rain. Right? Both of those result in no rain at the end. Right? So since we have two branches that are included in the probability, we're going to add them. We're going to multiply as we go down the branch, across the branch, and we're going to add as we include more than one branch. So this would be the probability of clear and rain, or since we're okay with either one, clear and no rain or cloudy or no rain. We just don't want it to rain. That would be the probability of cloudy and no rain. Put a space there between no and rain. All right, so now we to find the probability of clear and rain, we're going to multiply the 0.28 for the probability of clear times 0.96, the probability of, no rain. I wrote rain over here. Well, I meant to say no rain. I think I even said no rain. Somehow the no just didn't happen. Right, so that would be 0.28 times 0.96. And then we add, because we're including more than one branch, what we got when we multiply 0.72 times 0.69. Right, so 0.28 times 0.96 is 0.2688. I'm going to also put that over here. And then the probability of cloudy and no rain is 0.72 times 0.69, which is 0.4968. So there's only one we didn't find. We didn't find the probability of cloudy and rain. Let's find the probability of cloudy and rain. All right, so now we take the cloudy path again, but now we go down the rain branch. So the probability of cloudy and rain would be 0.72 times 0.31, which gives us 0.2232. Right, I'm going to write that also in the diagram, in the tree diagram here. What would we get if we added all of those together, I wonder? Let's add them together. All right, so I'm going to actually use a calculator because it'll be, you know what? Could probably just add it up. So let's see. It's not too hard. 28, well, that's 0. And I carried 2 over, right? Because that would be 20. So 9 plus 9, and then I carried 2 over. So I can give each one of them a 1. That's going to be a 0. And then I'm going to carry another 2 over. So 9, 10, 11 plus 6. That would be 17, 18 plus the 2 I carried over, that's going to be a 0. Right? And then, what was that one? That one was that 20? I think so. So we have 4, 6, 8 plus 2 more, that's going to be 10. We have 4 decimal places, 1, 2, 3, 4. Look at that, it's 1. When we add them all together, the probability is 1. So it doesn't matter which set of branches you're going down. Right? When you look at your 2 options, clear and cloudy, rain and no rain, or if I go all the way down the branch, clear and rain, clear and no rain, cloudy and rain, cloudy and no rain, no matter what, it adds up to 1. Right? And that's going to be true for all of our tree diagrams, that at any given stopping point, if you go down all the branches, it's going to add up to 1. Now, it adds up, where we have the rain and no rain, that's not an ending point. So that's why it adds up to 1 just for clear and just for cloudy. Right? But if we go all the way down the branch, those will all add up to 1. And on any individual branch, your choices on the branch adds up to 1. Let's find the only conditional probability problem I put up here, and that is the probability of cloudy given no rain. Right? So that line there means given. Let's find it the traditional way. So that would be the probability of cloudy and no rain. I'll just put no. You know it's no rain. Divided by the probability of no rain. Well, we know already the probability of cloudy and no rain because we figured that out. It was 0.4968. If we divide that by the probability of no rain, we get, surprise, surprise, if you divide 0.72 times 0.69 by 0.69, you're going to get 0.72. So we don't even have to use the formula if it's conditional probability with a tree diagram. The probability of no rain, probability that it will be cloudy, given that there was no rain, is going to be right here. All right, so that's why I said you work backwards. You don't include this number, all right, because you're going down this pathway, and you already have the no rain. That's already occurred. If you multiplied them, you'd be finding the probability of cloudy and no rain. You want the probability of cloudy given there was no rain. So you choose the pathway, and it's simply the cloudy. If you forget, just do it the way that we've always done it. And you'll get, I'm trying to move that little thing up there. There we go. And you'll get the right answer, right? So you can do it the long way, or you can remember, choose the pathway. You won't include the probability of the no rain part because you're not going down the pathway. You're going the other direction, and you're just finding out what's the probability of it would be cloudy if there was no rain, right? The probability to be cloudy if there's no rain would be 0.72. Right? All right, so that's enough of this tree diagram. Let's do another tree diagram. And this one we're going to make. So we have a survey of Pleasanton teenagers was given. 60% of the responders have one sibling. 20% have two or more. Of the responders with 0 siblings, 90% have their own room. Of the responders with one sibling, 20% do not have their own room. And of the responders with 2 siblings, 50% have their own room. All right, I'm going to write these as decimals, right? Because that makes a little bit more sense using decimals rather than percents. And remember, the sums on any branch have to add to 1. So sums of choices on any branch add to 1. All right, so we're starting off with number of siblings and then room, right? So we're looking at, because it says other respondents that have one sibling, of 0 siblings, this many percent have their own room, right? So we're dividing it first by siblings and then by room. All right, so hopefully that'll fit. Actually, let me make that a little bit bigger. I'm known to sometimes run out of space. There we go. So we have 3 choices here. We have 0 siblings, we have 1 sibling, we have 2 or more. Okay, and 0 siblings, let's see, well, 60% have 1 sibling. And 20% have 2 or more. Well, it's got to add up to 1. If 60% have 1 and 20 have 2 or more, that's 80. There's only 20% left to have 0. Right? So we can just add that right here. You have 60 60%, oh, just put 0.6. 0.6 plus 0.2 plus something have to add to 1. And what would add to 1? That missing here, we'll put a little x. That x that we're missing, which is the 0 or more siblings, would have to be 0.2. And so that's 0. That's 0 or more, just 0. 0 or more, that's everything. All right, so now that we've got that part broken down for each one, we're going to figure out if they share a room or not. Share, don't share. And every one of these original branches gets divided into share and don't share. And each of these branches, these two branches added together, has to be 1. Because that's really all the choices that you have, right? Either you share a room or you don't share a room. What else could there be? Besides something very silly. All right, so let's take a look at the responders with 0 siblings. 90% have their own room. So if 90% don't share, maybe instead of don't share, I should put own. Share, own. Since the words was own. I'm going to change the word share, since it says own in the problem, to own. Don't share, own, same thing. But if you haven't written it yet, own takes up less space, so that's be a good reason to put own. All right, so 90% have their own room, so that's 0.9. Together, these two have to add to 1. So if 90% have their own room, then 10% have to share. One sibling, 20% do not have their own room, so they share. Together it has to add up to 1, so that means 0.8 have their own room. And then 2 or more siblings, 50% have their own room. Well, that must mean 50% share. All right, so now we have figured out our tree diagram, and we're going to find a couple probabilities. I think I'm going to add a couple probability problems to it. These were all conditional. I added a conditional in the last one. Let's add a non-conditional on this one. Let's find the probability that you have 0 siblings and you share, you have your own room. And then let's find the probability you have your own room. Actually, let's just find the probability of your own room. Probability, own room. All right, that's good. And we have lots of space for own room because that one will take up more space. All right, so probability that you have your own room given that you have 0 siblings. All right, so the given is that you have 0 siblings. This one is a little different, right? The other ones we started at the end, right, because we had, we were looking at the probability of the first given the second. This one is the probability of the second given the first. Right, so the probability that you have your own room given that you have 0 siblings, right? So you're going to only look at the 0 siblings path. You're not going to include that one because this is a conditional probability. So for conditional probability, the first one is already taken place, right? And then you find the probability of the pathway here. So it's going to be 0.9. Now, what if you weren't sure that that was right? You could always do it out the longer way. And let's do that and prove that it's 0.9. So own room, so this would, if we take, this would be the probability of, and I'm going to put 0 and own, since that way is going, that's the right way down the tree. 0 and own divided by the probability of own, or 0, excuse me, 0 is the given. So if we do it the long way, you're still going to see we get 0.9, because this would be, we would take 0.2 times 0.9, and then we would divide that by 0.2, and lo and behold, it's 0.9. So when you have conditional probability, you just have to go down the right pathway, right? And then it's the choice for that pathway, if that makes sense. And if you need more clarification, let me know, and I can explain it a different way. Probability, so this, remember, that line there means given. The probability you share a room given that you have one sibling. If we weren't sure, we can do it this way. The probability of share, and let's put the 1 first. 1 and share divided by the probability of 1, because 1's the given. Right, so this is the given. The one that comes second is the given. And I'm going to have to go underneath because I'm running out of space to go across. All right, so probability of 1 and share, right, that would be 0.6 times 0.2 divided by the probability that you have one sibling, which is 0.6. Well, if you multiply 0.16 times 0.12 and then divide it by 0.6, you're going to end up with 0.2. So with a conditional probability, just choose the branch and look at the probability at the end. All right, so it's a little different. I'm going to actually write that down. So for conditional probability, choose the right end branch and find the probability. And it's always the probability of the first of the, so it's A given B. So find the probability of A for A given B. Or you can use the formula. All right, so that's your other option. All right, so you can also use the formula. It will work the same. So if you get confused, just use the formula. All right, let's look at the last one here, probability of your own room. So that's going to be, because I thought we should do another one where we have to add some branches. So that could be the probability you have 0 siblings and your own room, plus the probability you have 1 sibling and your own room, plus the probability you have 2 or more and your own room. All right, so here we're going to multiply when we go across the branch, add to go down the branch. So 0 and own room would be 0.2 times 0.9 plus, because this is or, right? This or that or the other. We don't care how many siblings you have. We just want to know you have your own room. Probability of you have 1 sibling is 0.6. Own room is 0.8. And then probability of 2 or more is 0.2. And your own room is 0.5. Remember, anytime, so here's a way you can check if you make a mistake. If you ever get a probability more than 1, then you are wrong, because probability has to be less than 1. So 0.2 times 0.9 is 0.18. These are an easy numbers. 0.6 times 0.8 is 0.48. And 0.2 times 0.5 is 0.1. And if we add those together, I wonder if I can move it up just a tad. I'm just a little concerned making sure you can see it. So here's a good example for going down the branches, because we had 3 branches to go down. So by the way, just in case you were confused at all what branches we went down this one and that one, and this one and that one, and this one and that one. I didn't connect my branches just because it's a little easier for me to write the probabilities at the end. All right, and finally, the drum roll, please. 0.18. 0.18 plus 0.48 plus 0.1 is 0.76. So 76% of the time the students had their own room, and that's probably all you care about because you didn't want to share a room anyway with your little brother or sister, right? Boy, that's a horrible looking decimal point. So thank you for watching this video. That's all we have right now on tree diagrams. The next video, which is tomorrow's video, is going to be a little review, and we're going to do a Venn diagram with Sam I Am. So come back for that. Thanks for watching. Bye for now.